So as you all remember from part 1 of this series, there's a glitch in our program, and for the two display instructions in the middle, they have a number carried on from the previous. Well, I found the fix for it now. Now I've made it so that when the scanner sees either a new line character or an ending character, it's gonna automatically end that line and end the iteration through it. And now it works perfectly as intended. There is no longer that number glitch that comes with the dis instructions in the middle. So there are 4 different instruction operators in our program. There is dis, add, mov, and joy. Although the joy is not supposed to be an actual instruction, so we have to find a way to limit and gatekeep which 3-letter words can be made into an instruction operator. So I'm going to create another struct. Type def struct iType, which means instruction type. Now, so far there's going to be 3 official instructions: dis, add, and mov. And yeah, it's going to be a 3-character array. So that means right now we have a total of 3 different instruction operators. So define ops 3. Right, and then we'll make an array over here. I type I types ops. And these, well, let's also add comments. Max, well, all the instructions, and this one is all the instruction types. Alright, and now we're going to declare the op for each of the 3 iTypes. So, alright, now let's create a for loop here. Int c equals 0, c less than ops c plus plus, and then for int d equals 0, d less than 3, d plus plus. Right, and then this is going to be used to assign all the iTypes, assign all the character arrays for the iTypes. So we're going to need a big char array to reference it. So char instructions. How about inst string, and then equals, and then let's see if we can declare it this way. Right, and then non dis mov add. And then so there's 4 ups and then 3 characters for each I type, and then there's gonna be 4 I types, so 12 characters here. Zero dot up D equals, and then okay, so it's int string. Well, let's make it 12. Alright. Inst string C times 3 plus D. And then after it's finished, we're also gonna have to print out all the I types. So int E equals 0, E less than ops. Wait, or we can just make it print right here. Printf I type C dot op, and then I type and \n at the end for a new line, and then %s. Yeah, like this. So then save, run the program, and hey, we have all 4 of our I types correctly. Alright, first we're gonna want to make it be able to print out the values of each register. That way you'll know what the values of each register are. So declare a void method here, void print regs, and then parentheses semicolon, and then at the bottom you're gonna write it void print regs. Alright, and now make a for loop, int I equals 0, I less than 16, I plus plus. Printf, right, and then r %d, where that number is going to be I, and then /t for tab equals, and then /t for tab again, and then another %d, which it's going to be registers I. And now, for example, let's set one of the registers to 10, and then another one to 20, and then we go back into the main method somewhere towards the beginning, and then make it call the print regs, later on this method is going to be called every time the program detects a dis instruction. So now let's compile it. Yeah, I should have added a new line. So let's... Alright, now I've added a new line at the end. Alright, now you've got register 3, which has a value of 10, and then register 8, which has a value of 20. Now, this is good. And yeah, so right here in the print regs I've added the new line right here. Now we're going to try to make it so that the print regs is called every time we run into a dis instruction. So we're going to go right here, right after the part where it derives the instruction operator, the instruction type. So, and then if, now there's a string compare we should do. So if string compare, because this is how you're supposed to compare strings, since doing the double equals doesn't actually work here. And then this, and then equals 0. Then it does the print regs. Now let's see if it does print regs for every time it runs into the dis instruction. Oh, it does. Alright, now this is a step in the right direction. Though we still have one problem though, and that is this right here, the instruction type joy, which isn't a valid instruction. So we're going to be fixing that next. So we're going to do a, well, let's create a boolean variable, although there's not really such a thing as boolean in C, so instead we just do integer, and then we'll call it is valid up, and let's set the default to 0, which means false. So somewhere around here we do a for loop, int h equals 0, h less than, let's see, we have 4, so h less than 4, h plus plus, yeah, ups. We have 4 different types of instructions, aka I types. So then in the for loop, it's going to look through every element in the array called itypes. So if string compare actually let's instead of this valid up, let's make it be an up index, and it's not going to be representing a boolean index for instruction type. So let's set it to -1 as default. Then a string compare of ints.up and itypes. Have to make sure you get the casing correct. Yeah, it's all lowercase. So itypes and then h equals to 0. Then up index equals to h. And then now for everything below this, if and then everything below this is going to go inside the if statement. So if up index is greater than or equal to 0, and now we're going to see if this omits the joy command, and let's comment out this line that prints the registers. Okay, so it actually stops here after instruction type this. Oh, I see the problem now. It's comparing a character array to this object. So now we're going to compare it to the .op of this object, so it's the character arrays. Alright, so the instructions array is called inst, we're actually going to rename it now to imem using the replace tool in Notepad++. So yeah, now it's imem. And then instruct, instead of using a 3-character array, we're just going to be using a singular integer int opcode, and we're going to initialize it to -1. Yeah. We're still going to keep the I types because we need those for the string comparisons. But yeah, once we go down here, I'm going to declare a new character array. Let's call it the up, and then a size of 3. And then in this for loop, it's going to compare. In this first for loop, the characters are going to be sent into the up I equals line I, and then it does a string compare for the up to I types h dot up, and then up index equals h, print instruction the up. And then we're also going to add another argument here, h. Well, how about up index instead, and then %d, and yeah, let's separate this a little so it's easier to distinguish the different lines. And then imem pc dot opcode equals up index. Well, at this point we don't really need the up index anymore, so let's actually delete up index and make imempc.opcode equals h, imempc.opcode, and then replace it here too. Alright. And then we're going to scroll down to see any more instances of .up. Now it's going to be, yeah, .up code, but replace this S with a D. Now let's save it and then run the program. Yeah, there seems to be an error and it stops right here. So it means we might just have to make the up equals to 4, and then the up 3 is equal to this string ender. And now after running the program, we get the instructions opcodes of 1, 2, 1, 2, 1, 3, that being 1 for every dis, 2 for every mov, 3 for the add. Although we have a different problem now. As you can see, it stops at this add instruction and it doesn't reach this dis instruction all the way at the bottom. Although on the other hand, if I add 2 more dis instructions, then we get a slightly different result, where it will include the first 2. So yeah, really this program is missing the very final line. And so this means that your assembly code has to have an extra line at the very end, and yeah, let it be a blank line. And then you could type anything you want in that line. It's not going to be read into the program. Okay, now we're not going to want the command prompt to be filled with a bunch of information and letters. So now we're actually going to remove a lot of these print statements. Like this for loop right here, all it does is reprint every instruction at the end. So yeah, delete. And at this top right here, where it prints out every I type, let's take that out as well. And then at the part where it says instruction type and then prints it out for each instruction, take that out as well. And then at the part where it says set number, yeah, delete this line as well. And then delete this else statement. Well, this little one. And then, alright, next we're going to want this program to actually execute the commands. So then, after it finishes gathering up all the instructions, we're going to reset register number 15 to 0. And then we create a while loop. While registers 15 is less than, and then well, we're also going to need to keep track of the total number of instructions. Int I count equals 0, and that's what we had. Instead of incrementing registers 15, this was actually supposed to increment I count. So instead of PC equals registers 15 here, well, actually we're going to delete the PC variable entirely. And then anywhere else where PC is mentioned, it's going to be replaced with I count.
So I'm in I count. And then right here, I'm in I count. Alright, I think we do it now.
And then just remove registers 15 here as well. Alright, now this while loop is going to be while registers 15 is less than I count. Because if we have a total of 7 instructions and I count started at 0, it's going to end up being 7, and then the index of the last register is going to be 6. So yeah, while it's less than I count, if I mem registers 15 dot opcode, and let's add extra parentheses just in case, and then equals equals to 0, it's going to print null. Else, and then if it equals to 1, it's going to do print regs. And then if it's equal to 2 or 3, then it's going to do, yeah, we're going to create 2 new functions in this program. One is going to be called mov, and one is going to be add. And right now they don't have any arguments inside them yet, but I'll add them later. So now, and then we're going to declare mov and add here. And first I'm going to attempt to pass the instruction into it. So the type is going to be instruction inst. Right, and then void add, and then copy both of those, paste them down here. Right, and then yeah, mov immpc, add immpc, instruction inst, and then first I'm actually going to run the program right now to see if it's able to pass and receive the struct. Oh, and I also forgot a semicolon right here. Alright. And then we're going to make sure that it actually increments, so registers 15 plus equals to 1. Right, and then we're not going to do anything related to the mov and add yet. We're just going to see if the print regs are being executed. And it works. So it did it once, twice, thrice, fourth. Right, so yeah, it printed the disk command 4 times. Alright, now we're gonna do the mov and add commands, instructions. So inst dot nums 0. We're going to declare a few integers here, int reg and amount. Reg equals nums0, and then amount equals inst.nums1. Right, and then for add, int source1, source2, dist, which means the 2 source registers and then the 1 destination register. We're also going to declare int amount1, amount2, and result. So amount1 equals inst, well, actually let's start with these. Source1 equals inst.nums0, and then source2 inst.nums1, and then inst.nums2 will be dist. Then amount1 equals to, right, and then the registers array is just called registers, so registers source1, amount2 equals registers source2, and yeah, registers dist, we get result. Well, this should actually be flipped. Registers dist equals result, because, and then over here result equals amount 1 plus amount 2. Right. And then for mauve, we're gonna also update, so registers at reg, I might as well also name it dest as well. Dest equals inst num 0, and then registers dest is now equal to amount. Save and then run. Alright, now things are working in our favor. The first mauve command changed R5 to 65, the second one changed R1 to 99, and then the add command, well, the add instruction added R1 and R5 together to make R2, and yeah, everything's been working well so far. So behind the scenes I'm gonna make more instructions. Later I'll come up with a third video that will get even further and deeper into this.